And for part B, so it says let y equal f of x be the particular solution to this differential equation. And the graph passes through the initial condition, point -2, 8. Does the graph of f have a relative minimum, maximum, or neither? So now we have to think about what makes a relative minimum or maximum. First of all, the big thing here is relative mins and maxes can only occur at critical numbers. And critical numbers happen where the derivative equals 0. So we're going to see what the derivative is, which we're given, dy dx, at the point x -2, y is -8. Now, if this isn't 0, then -2, 8 is not a critical number. -2 is not, and it doesn't have a min or a max. So we're going to plug it in. So -2 squared is 4, minus 1/2 times 8, which is 4. So that's not surprising. Otherwise, it would be a very simple question. -2 is a critical number, so there could be a relative min or max there. It still doesn't have to be. So to figure out if it's a relative min or max, usually we would see if the derivative goes from negative to positive at that point, or we can use the second derivative test. We already found the second derivative, so that's going to be much, much easier. Oh, look at that, it's right here. Here's the second derivative we got from part 1. So now we're going to figure out what is the second derivative at this critical point, -2, 8. So we're just going to plug it straight in. 2 times a -2 minus, we already know this derivative is going to be 0 because we already did it, but 1/2 -2 squared is 4 minus 1/2 of 8, which is 0. So the second derivative is -4. By the second derivative test, that means that critical point we plugged in is a maximum. So I would write here, just make sure you're justifying your answer, since the second derivative is less than 0 at -2, 8, that point is a maximum. That's what the second derivative test tells us. So that was part B. Part C is next.